Thanks very much, Joost. Well, thanks very much again for coming this afternoon. As you said, my name is Pascal Coulon. I'm from a company called Sysys. We are a British-based company, system integrator, and really our drive is to integrate GI or geospatial solutions within the business or enterprise solutions. So really today I'm going to try to take you through the various steps that at Sysys I follow to try to design and implement disconnected GI mobile on an open source platform, or actually probably more an open architecture. And really what I should start by addressing is what were the main drivers and considerations for us to try to move towards an open architecture. Well, the first aim really was like we all are over the last few years, we need to really reduce cost. But it's not just a question of reducing cost for the implementation of the solutions. It's also in terms of licensing, support, data, all these key elements of the solutions. As you probably know, in Europe and particularly in the UK, we've got a strong emphasis from the governments to push us towards the use of open data, open source solutions. So that was a key driver for us. We also needed to look at the interoperability, but not just at the level of data. We needed to start considering interoperability at the level of the technology, the software, the hardware. What can we do to essentially future-proof the solutions and eventually try to reduce the risk to be vendor-locked? So I like to take a bit of an analogy when I talk about an open architecture. Yes, like Wikipedia will tell you, it's it's a set of computer software which is there to help you to quickly swap component. But when you consider that with Lego, and I think it's a reasonably good analogy, you end up being able to swap components, and from those little blocks being able to build pretty much anything, because essentially it's in a bit of an open format. You're able to change the component easily from a red block to a green block, from a small to a large blocks. And the key thing is none of those blocks have got any business logic in it. And that's one of the key elements that we had to really govern as we designed and implemented the solution, is to remove any business logic from any of the client or data tier. The business logic should sit in the middle. And combining an open format with decoupled component, that's what drives the interoperability of your components. And ultimately, what will help you to reuse numbers of components across your solution, and therefore drive the cost down as you implement your solutions. What I'll try to do is, over the next few slides, is take you through 5 key points to try to increase the curve of your open architecture. And each time we'll go through one of these key governance points, we'll get 1 star and so on, and see whether or not it is practical to put them in place, what are the pros and cons of implementing those various governance rules. So the first one is open source. Yes, I'm sure we're all sold on the idea to use open source, particularly at FOSS4G. But we have to still sell open source to our clients. It's sometimes quite difficult. But I think in our case, it was quite obvious that open source was a strong contender. It's really well suited to deploy it on large numbers of devices. We are in the GI industry, and the GI industry has benefited from open source product for a long time, and we are very good with open source to follow open standards. So that's again another element which, glued together, really give us a strong emphasis to future-proof the solutions. But again, when it comes to open source, yes, we've got the ability to really understand the level of security because we've got access to the source, and it is a proven technology, is reliable. Any major defect will be fixed very quickly by the community. And it goes without saying that as well, now across the UK and Europe more widely, there's more and more recommendations and direct recommendations from the government, like I mentioned here, where they actually directly tell us, well, no, go for this type of open source product. But is that really just a clear answer? Maybe not. We need to be a bit mindful. And what I always use as an example when I'm saying, yes, open source is a very credible product, we've got two of the key mapping agencies across Europe, IGN in France and Ordnance Survey in the UK, who not only are actively using open source product, but are actually funding the development of those products to make it, for instance, Inspire compliant across Europe. So there's a clear evidence here that, yes, open source is the way forward and should strongly be considered. Interoperability, that's going to give you 2 stars. And this is all about how are you going to glue the various components. We've got all those Lego blocks again that I use as an analogy to start with. And this is very much what will help you to disseminate the data between the various components of your solutions. Because we're going to be using WMS, WMTS, we are fully able to actually swap between GeoServer, Map Server, OpenLayer, Leaflet. That's the beauty of it. We are not constrained to stay with one product, as one might actually disappear, because open source doesn't mean that it's going to stay here forever. We can swap with a more up-to-date technology. Now, there's a lot of debate around, particularly obviously in the mobile industry. Should we go for native or non-native, or the like of HTML5 technology? In our instance, I think HTML5 gave us a strong headway, really, help us to implement solutions which could be easily deployed on multiple type of device. That means different type of, obviously, operating system, as well as different type of screen size with responsive design. Now, again, HTML5 brings us additional advantages, particularly in the GI industry. We've got the ability to do caching. Be small amount of data can be cached, it can still be beneficial. We've got geolocations API. So all these elements combined brings us a lot of advantages, and it goes without saying as well, there's a numbers of JavaScript API. I think we've got a few presentations afterward which highlight that fact, which are really well integrated with HTML5 and give you rapid development with big end user component, helping you to drive very nice design. Optimise storage. That has been one which caused us a lot of challenge. We had to be really mindful of, obviously, the fact that we were in a disconnected environment. Our end users, they're not working in urban area. They're actually working mostly into remote area where there is very poor connectivity. I was looking around this morning for the sort of combined coverage, mobile coverage map in the UK, let alone. And actually, in most part of the UK, there's very limited or poor 3G coverage, even nowadays. And combined with the fact that we are looking at GI applications, those type of applications are hungry in bandwidth. So we really need to enable the end user with all the data on the device. And I'm including in that the like of what we call OS Master Map in the UK, this really fine detailed mapping, which could take a large amount of data. And we only have a few gigabytes of space on our device. We also need to start thinking about the business data, which in our cases was over millions of records that needed to be displayed like the client would really want, with the right styling, but needed also full access to all the attributes to be able to be queried. So really the key story here is you need to engage with your stakeholders very early on. You need to understand what are the priority. Do you want to really display master map with the full color coding, with the topographic area, as we call it, or would just a topographic line be sufficient? Are you looking at generalizing the data? All those questions need to be asked very early on with your end users. You want to make sure that you engage with your end users, otherwise there is a high risk that they will not start using these applications as it comes live. You also need to look at interoperable data format, the like of ST geometry and so on, so that you've got the ability to swap again server more coarse component for serving the data to the rest of the applications. Now, one of the key challenge we had was the provisions of the base mapping. We decided to use the like of tile cache. Tile cache is great. It's an open format and very efficient, because actually you don't even need any sort of server layer to provide the data. You can access it directly through a web accessible folder. Now there is a bit of a downside to it. Yes, the smaller the tile is, the quicker it is to provide the data, but actually the more space it takes on your hard disk, because at the end of the day, those little tiles, those little files will go under the threshold of the block size on your hard disk. So you need to be very mindful of performance versus storage space. And we find out actually that particularly when trying to cache the like of master map data, especially in rural area where there's very little information, the best was 512 pixels by 512 to have the optimal performance, but also the best storage. Now, really, the next one is all about user interface. That's a key element, again, when designing a mobile applications. You need to be very mindful of where the user is going to have access to the applications. Are they more extreme environment? Are they urban areas? So you need to make it simple, decluttered, large icons, lots of user feedbacks. And indeed, again, that goes along with the idea of reducing the cost. You need to really embrace the concept of responsive design, which goes well with HTML5 indeed. So let's have a look at the solution building block. We were fortunate enough for the first device that we had our hands on is to go for a Windows 7 tablets. And those tablets are very powerful. Dual CPUs, large amount of RAMs. So we decided actually to go for something which might sound a bit audacious, but we decided to start storing the data in Postgres with PostGIS, which gave us a strong way of managing the data, loading it in a convenient way. Serving the data was actually done by GeoServer, all loaded onto the local device. One thing to consider there, and lots of people are thinking, wow, GeoServer, really? On a mobile? But yes, why not? You've only got one user. And those tablets are very powerful. And I can guarantee you that we're capable of serving several hundred thousands of features within sub-seconds to the end users. So this is a credible solution. But again, we wanted to remain as open as possible so that GeoServer was not performing to the right level. We could actually consider alternative options. So any of the data would be served through WMS, WFS, WMTS. And I mean, again, the usual suspect really in terms of implementing the client applications. We're looking at the like of OpenLayer, JavaScript, jQuery mobile, very convenient type of product, allowing us to quickly implement the solution and integrate it into existing forms, or even integrated with the local GPS on board of the device. But the key things, as I mentioned, is we've got the ability to actually swap Postgres with SQLite. There's no problem. You can do that. And that's still going to work, and you don't have to re-engineer the whole solutions. Maybe you would rather have leaflet rather than open layers in combinations with map server. Yes, you can do that as well. Now, as I suggested early on, yes, open source is great, but you need to be mindful actually that it's not always possible to go full open source in an organization. So you need to think about a touch point with other commercial product, which is actually one of the challenges we had here. We needed to enable touch point with the like of a full-on Esri enterprise architecture. But we also needed to make it simple to the end user to upgrade the base mapping as well as their business data. Just as a simple click, they needed to just have the data downloaded and dispatched. So that was actually enabled with the like of tile cache, indeed, again, to generate the base mapping. And GDAL, OGR, has proven a really good, strong ally for us in terms of synchronizing the data with our central data store. But again, because we decoupled all components in the solutions, we have the ability to actually queue the various data captured on site and synchronize it at our convenience and using open components. So we've learned a lot of lessons, and the key one is around open source. It was new to our client to start using open source. You've understood they were primarily using Esri. But yes, open source is a great way to reduce licensing. Yep, you don't have to pay anything when you deploy it across your mobile device. There's no maintenance cost as such, as you get the patch whenever you want, you apply it in whenever you want. However, and there's a strong message, that's a very valuable one to actually demonstrate the power of open source, is you don't have to be alone with open source. There is commercial solutions to support it. And that was a key enabler to demonstrate the power of open source. You've understood that the map cache was for us something that we had to work quite hard on it. And it's really about trading off performance versus storage size. But the use of a map cache should not just be considered for the base mapping. That's what we've discovered as we started to performance test the applications. Actually, for reasonably static business data, don't hesitate to cache it as well. That will obviously dramatically improve the performance of the applications, particularly in the case where you've got end users keep using the applications in the same location time after time. They might be surveying water meters into a street for days and days, and the data will be there for them, will be fetched once, and they're available for the duration of their survey. So it's a great way to really improve the performance of the applications. And it goes without saying that because we use the OpenGI format, both at the level of storing the data and serving the data, we've really enabled openness in the architecture. And yes, HTML5, there's a lot of debate. We've seen the big player like Facebook, LinkedIn, they've all swapped to native platform. But we still believe that HTML5 was a key enabler for us to quickly implement the solutions for, particularly on the client side, enabling us to deploy it on tablet PCs, Windows tablets, or iPads, and so on. However, we're mindful that if we start needing more low-level functionality, we would probably need to start considering a more native implementations. So thanks very much again for coming this afternoon. If you've got any questions, please do ask. Otherwise, you've got my contact details, and feel free to contact me at a later stage for any discussions or questions.
Okay. Thank you very much, Pascal, reminding us the usefulness of open source and some of the issues with mobile development. And we have time for at least two questions, and this gentleman.
So, for a average performing current day phone, what kind of performance are you getting? Are you quite satisfied with it, or?
Yeah, very much so. I mean, we're able to zoom from UK level all the way down to master map at the same performance as if you had Google Map in front of you. Essentially, you pinch the screen and it just zoom all the way down to master map. And even master map at the level of, let's say, Nottingham, on a fairly high level scale, I'll get about 2 seconds, 3 seconds max to get the data. And we've got large numbers of point data, 170,000, thinking about it. And it takes us about 5-10 seconds to get national coverage coming back in one go. So GeoServer was a bit of a scary thought at first, but actually it does work for one user because those tablets are these days very powerful. So we should not discard it.
And are you doing any feature editing or considering anything like that?
We do, yes. We've got the ability to scribble, but the key things, again, for us, we are not, even if it was connected at some point or synchronizing, we're decoupling everything. So every single feature captured is stored as the like of GeoJSON and then used by a service-oriented architecture on our central infrastructure, enabling us to do long transactions or versioning and so on.
So actually we have some time for more questions. Just gentleman over here.
Yeah, a couple of questions. Have you actually got a tablet that you could sort of show us? I mean, not now, but sort of.
Yes, I could show you something. Probably yes, on an iPad later on. I could probably show you something
On an iPad, but I thought you said it was a Windows 8 tablet.
Yes, but we've already ported the front end onto an iPad.
Oh, okay. Because I was particularly interested in the combination of technology.
Otherwise I could. Yeah, come and talk to me later on, and I'll show you something.
What was the deployment like? So I'd imagine that would be pretty complex, putting the whole stack.
Yes, that was one of the
rolling out the software.
You're right. It could have been challenging, but we've got a very good build manager back to base who's done a fantastic job and he's put everything into a simple executable. So the ICT guys are just doing simple Windows installations, install JT, and then deploy Chrome automatically because he works on Chrome primarily well, and the whole of GeoServer, Postgres, the data is all loaded automatically. So it took a bit of effort, but it's simplified, yes.
Just one question or comment. You talked about the issue with the tiles and not using space efficiently. I wondered if you looked at the MB tiles format, which sort of gets over that to some degree. It's a slight performance overhead, but
yes, I did look into this element, and I think at the time I might need a bit of discussions with you. I did not find the right way to serve it into the like of open layers. I wanted to really bypass any the like of GeoServer and so on for serving my base mapping. I really wanted a direct access.
yeah, I think tile stash is something worth looking at.
Okay, that's useful noting. I mean, one key thing to note is this was thought and designed around about a year ago, and one key observations I've had over the last 3 days with the AGI conference and now FOSS4G, there is a massive evolution of technology. We're now looking at querying data directly from HTML5 to backend database. So yeah, I think there's a leap forward, and the whole architecture probably need rethink, but there's some strong ideas here.
Yeah, we go on with questions. The next session will start at 3.
Hi Pascal,
Hi,
Simon Redding, Environment Agency. You mentioned iPad port, which is of great interest, but what kind of software stack did you use to do things like, feature data collection on an iPad? Because running a GeoServer on an iPad ain't going to work very well.
No, we're looking at the front end particularly, which is using the like of open layers, and what the key things for us, because we have the ability to connect to a backend infrastructure, for us everything is decoupled. So we are storing the data locally as open format, the like of GeoJSONs, whatever really is convenient to open layers. And then that information is then queued back into our internal infrastructure and ultimately committed to the central database.
So we have time for one question. Then. So. Okay.
You were speaking for performance about tile size, and I was wondering about how do you deal with latency in mobile because I know that you were speaking about the storage, but my main concern is about the latency you have on a network on mobile. How do you deal with this, or how do you evaluate this use case?
Well, the first thing is to note, you mentioned network. We are in a fully disconnected environment, so we don't have any latency on that front. And in terms of technology, in terms of storing the data, we've used solid state, as it is with any modern tablets. And when you consider the millions of little files in a tile cache, for instance, this was of a great benefit, obviously, to have a solid state.
Okay, thanks again, Pascal.